The continent is one of the geological paradise. Mountain ranges called as Andes, which kind of stand out when it comes to the physical features of South America. So friends, important for your exam. Where can we use the information of Andes? In our mains examination. The longest mountain range in the world. It is also a part of Lithium triangle. You will see it's written as Falkland Islands, and in the bracket it is mentioned as UK. A river Medria that is joining the Amazon River. It's the largest tributary, Lake Titicaca. So you can mark that. It's highest navigable lake. You should look at your atlases. Towards the last pages of your atlas, there's a map mentioned about. Hello everyone, welcome to another episode of the Continent series. This is one of the attempts that we take you through various parts of the world to give a different perspective of geography. So this is our third episode, and here we are starting with the South America. The continent that lies in this, mostly in the southern hemisphere, is tropical, has equatorial climate, has temperate climate, has mountain ranges, and so on. So let's dive deeper into what is about South America. And I hope all of you are getting connected to this new series, our new an attempt to make geography clear through maps. So Continent series, episode 3, let's begin with the map of South America. Now, the continent is one of the geological paradise. When I'm saying this, it means that we have a lot of new features, young features, like you can see Andes to the western part of South America. Then there is a shield part lying to the eastern part of the continent. There are central lowland. The continent has Pacific coast along the western side of it, Atlantic coast to the eastern side of it. So as we did in the previous episodes, similarly we are moving with the physical map first and then looking at some political aspects. So where the physical map is concerned, South America has lots to offer to understand geography. Like the division, if we go by the physical division, we find on the western coast of it, the western coast of South America is the Pacific coast that stretches north to south. Then there are these mountain ranges called as Andes, which kind of stand out when it comes to the physical features of South America. Towards eastern side are these Brazilian highlands, right, or these highlands. Then central region is the lowland region. Towards the northern side of it are Guyana highlands, and southern part are some series of islands in Terra del Fuego, and islands to the eastern side of the South America called as Falkland Islands. Let's have a discussion on all of these. I'm starting with the first important aspect of South America, Andes. So friends, important for your exam. Where can we use the information of Andes? In our mains examination, as an example of young fold mountains, as an example of mountain ranges which are located at the coastal range or at the plate margins, and few more examples. They can be also important for your prelims examination, right? It has a lot of volcanic eruptions, a lot of volcanoes, folded mountains, and a little bit more to understand how plate tectonics have shaped the fold mountains. So let's see Andes. So let us try to figure out in South American continent. So let's suppose this is the continent of South America, and here to the western side lies this range starting from Isthmus of Panama to the Strait of Magellan. Strait of Magellan. That's the stretch of the world's longest mountain range. So that is stretching all the way across western part of South America. The longest mountain range in the world, the second highest mountain range in the world, and yet another example of the young fold mountains. In the previous discussion, we discussed about Rocky Mountains, and we mentioned there Rocky Mountains are not like Andes. But then question is, what about Andes? Andes also have to offer, like for example, Andes, the formation of this mountain range is again an outcome of compressional forces. Now these compressional forces are acting because the plate of South America collides with the western part collides with Nazca plate. Nazca plate is an oceanic plate. It diverges from Pacific. You can consider that as minor plate. Now, minor plates are those which are a part of bigger plates, major plates, and Nazca plate being one of the most active plates. If present geological period is concerned, Nazca plate is the fastest plate. In the past period, like tertiary, by the end of tertiary period, Indian plate had collided with Eurasian plate, and in the entire tertiary period, which starts from about 60 million years before present, Indian plate was considered as the fastest plate. It has slowed down a bit because it has almost collided with the Eurasian plate, but Nazca shows the maximum speed. Now, you should look at your atlases. Towards the last pages of your atlas, there's a map mentioned about the plate tectonics. My request to all of you is just go through that map once, where you see various plate boundaries mentioned in your atlases. There you can figure out, there you can mark the plate, Nazca plate, and the South American plate. Now, this type of a plate boundary is between an oceanic plate and the continental plate. The convergence between these two plates form a unique blend of fold mountains which get intercepted by volcanic features. So these are not completely the fold mountains. Yes, they are fold mountains, but the continuation of folding cannot be seen all across. This fold mountain has few volcanic features in between, volcanic mountains in between, which we'll mark in a while. So let's try to understand this. So here, suppose it's an oceanic plate. It collides with the continental plate. We discussed in the previous discussion, while we were discussing about North America, those who have not taken that, those who have not followed that, please, you can go through that first episode of the same series, where you find that the movement of plate boundaries we had mentioned a bit. I'm repeating that here, that these lithospheric plates are lying on a semi-molten material, semi-molten layer called as asthenosphere, and because they are brittle, they are lighter, they can flow, they can slide over this and are energized by convective currents generated deep within asthenosphere. The similar process goes on between this plate, what we call as Nazca, and the South American plate, but slightly different here. What happens here, the Nazca plate, being denser plate, actually subducts under the South American plate. Since it's an oceanic plate, the composition of oceanic plate is mostly silica magnesium. And that's a denser plate, so the denser plate subducts under continental plate, which is lighter. The sediments which are present here, sediments which are present at the margin of the oceanic plate, they are kind of scraped off, they are compressed, leading to the accumulation or accretion of sediments on the non-subducting plate boundary. Here the non-subducting plate boundary is South American plate. So as a result of this compression and scrapping of the sediments, fold mountains have been formed. Fold mountains have been formed, which we call them as Andes. Okay, so these are again tertiary fold mountains formed in tertiary period. And Andes fold mountains also have lot of volcanic eruptions. There are few volcanic peaks. We'll just mark what are volcanic peaks in between. So we also call this type of folding as an Andean type of fold mountain. Andean type of fold mountains are those where folding along with volcanic eruptions are observed. So let's see some of the important fold mountains, important mountain peaks of this region. So friends, if you look at your atlas and you have the map of South America with you, the physical map of South America, you can look at the southern part of South America. You need to go a little south of Tropic of Capricorn. There you'll find a mountain peak, Mount Aconcagua. Aconcagua. Okay. It's the highest peak of South America. An extinct volcano has higher elevation than most of the peaks. Next to that is one more mountain peak called as Mount Hojas del Salado. Mount Hojas del Salado. In your atlas, it's mentioned as Cerro Hojas del Salado. It's the highest peak, highest volcanic peak across the globe. Not just of South America, but across the globe, it is the highest volcanic peak. Besides these, if you come towards equatorial areas, you'll find some of the volcanic peaks again near to equator, as in there are some peaks like Mount Chimborazo, and Mount Cotopaxi. These are active volcanoes located very close to equatorial regions. And also you will find that the volcanic eruptions have happened. Just now we mentioned these are taking place because there's a continuous compression between these two plates, oceanic and continental plate. Now, interesting fact about Chimborazo. From the center of the earth, it is not the Everest that has the maximum elevation, or it is not the peak Everest that is the farthest place from the center of earth. From the center of earth, it is Chimborazo that is farthest from the center of earth. That is farthest from the center of earth. I leave up to you to understand this. All that you have to understand or remember is that from the center of Earth, equator has got a bulge and a mountain peak is formed over equator. So obviously from equator, Chimborazo is going to have farthest distance, the maximum distance from the center of Earth. So you can look at your atlases, kind of fact about Peak Chimborazo. So this is what Andes are all about. Okay, you can quote this example in a lot of other, while writing answers for the mains, giving an example of ocean continental convergence, or otherwise for prelims examination also it becomes important. So let's pay attention to one more features. Then very interestingly, as we go to the eastern part of South America, this part of South America, it's a Brazilian shield. If you find that in your atlas, it's a Brazilian shield. Now, what is a shield? In, again, episode 1, we have mentioned what is a shield and what do we consider about the shields and so on. In that, we had mentioned that shield consists of cratonic features. What are cratons? We have mentioned that in the previous, please follow that. Cratons are oldest rocks which were formed. These acted as the nuclei for continental accretion. These acted as the nuclei, the focal point for continental formations. There's a craton like Minas Gerais, a region of Minas Gerais in Brazil. It's a plateau region in Brazil that is known for iron deposits. That's known for iron deposits. Likewise, there are Rio Plata. Okay, Rio Plata region, Plata, Rio Plata region. That's again one of the cratonic rocks. Well, we don't have to memorize all the cratons of Brazil. Just remember Brazilian shield. And we had mentioned that if there's a shield, what is a shield? The exposed part of craton. Exposed part of cratons. And since cratons are metallic in nature, since cratons have oldest rocks and metals were first to solidify, when these cratons get exposed, we call them a shield, and shield therefore becomes rich in metallic deposits. They become very important for mining activities. So this Brazilian shield has one of the largest iron reserves in the world. In the Brazilian shield, which was formed in the Precambrian times, somewhere between 2 billion years to 3 billion years before present. That's the age of this Brazilian shield. In the Brazilian shield, you find very interesting feature and a very prominent feature called as Brazilian highlands. So important for few examples. I'll let you know which examples where can we use them. So you can locate Brazilian highlands in your atlas. So they stretch from eastern part, from the southern region near Uruguay region to the north plateau of Borborema. This entire stretch is a stretch of Brazilian shield, Brazilian highlands. Okay, as I mentioned, rich in iron reserves and so on. Then extension of the Brazilian shield can be seen in this northern part of South America. In the northern part of South America, there are Guiana highlands. Guiana highlands. What is it? It's an extension of Brazilian shield. Formation is somewhere around 2.5 or 2 billion years before present. And since it's a part of shield, it must be rich in metals again. So which metals do we have here? There are a lot of rich metals that we find in the region. Those metals include iron. These metals include gold and also bauxite. Brazilian shields. So far as the highlands are concerned, there are two major highlands. West is Andes, east are these Brazilian highlands, which are more like the plateau sort of. Here you will see the eastern Brazilian shield has, on the eastern margin, has escarpments. eastern margin has escarpments. Now, what is an escarpment? Remember that escarpments are steep sloped features. They're much like those steep sloped features. The angle of slope can be very steep, formed by two processes. The steepness of slope is maintained either by erosion or by the process of faulting. So sometimes faulting can cause it's a process of cracking and movement of the crustal blocks. So when crustal block move, it can move like upwards in case of reverse faulting, it can move downwards as a case of normal faulting. So in both cases, there'll be a steep sloped feature formed, which is referred as escarpment. In simple terms, I'll try to explain how do you call it as an escarpment. Let us assume any hill slope, okay, any hill slope that is steep, quite steep. And this hill slope has some weathered particles. Weathered means disintegrated particles. The rocks disintegrate, they break down, weathered particles. Now, these particles do not require any agent to carry them down slope. Okay, these do not require any agent to carry them down slope, means wind, water, glacier, etc. is not necessary. They will move downwards just because of gravity. So those slopes, the steepness of slope is so high that all the weathered particles, debris, broken rock fragments move down slope just because of their gravity influence and do not require any such features. These are called as escarpments, which can be an outcome of erosion or it can be an outcome of the process of faulting. Brazilian highlands show escarpments. Okay, let's move on to some other aspects. Highlands mein. Then comes plateaus. Let's go back to this. So here we have a huge plateau, often referred as antiplano, in the region of Brazil. Okay, you can see this part here. Antiplano in Bolivia. Okay, called as Bolivian plateau. Bolivian plateau. Now, it's a type of intermountain plateau, right? Because of continuous compression, some surfaces may rise like a table-land and is considered as one of the highest plateaus in the world. So, it can be considered as it is basically the second highest plateau in the world. Plateau of Bolivia has also got some economic significance. The plateau has rich tin deposits, and of late it is also a part of lithium triangle. Lithium triangle includes the region of Bolivia, region of Argentina, and the region of Chile, which has one of the largest reserves, in fact the largest reserves of lithium in this triangle. Bolivia is one of the part of the lithium triangle. And as they said, because of the e-vehicle revolution that the world is up to, or they're bringing e-revolutions, lithium is new petrol. Lithium can act as new petrol for making lithium ion batteries. So the significance of lithium has significantly increased over the years, and Bolivia can be one of the larger producers of the lithium, found in plateau of Bolivia. Right? In political map, we will look at the different aspects of this Bolivian plateau and the lithium extraction in the region. Let's move from here. We'll go to the eastern part of Brazilian highlands. Here, there is one more plateau. If you look at the South American map, to the eastern part, there is a plateau called as Borborema. The plateau of Borborema. The plateau of Borborema is an extension of Brazilian Shield, so I don't have to explain what is it important for. I hope you can all relate to it. It's slightly semi-arid in nature, okay, semi-arid in nature, but rich iron deposits, iron deposits. So friends, let's go to these physical maps once again. What we have mentioned in these physical maps so far. First, just for the sake of revising it. First, Andes mountain to the southern western part of it. Young fold mountains, formations. Go through that. Think about it. Guiana Highlands, part of Brazilian Shield. Brazilian Highlands, again part of Brazilian Shield. And you should also know what is Shield. Then the Antiplano or Bolivian Plateau. Okay, the Plateau of Borborema and their significance so far as the mineral formation and extraction is concerned. These are the major physiographic features of this plateau, of this continent. Going to the south of it, we find interesting features like Terra del Fuego. There are islands here to the southern part of South America called as Terra del Fuego, and to the eastern part of it are the Falkland Islands. So let's take an example. Let's try to relate to this island called as Falkland Islands. In your atlas, you will see it's written as Falkland Islands, and in the bracket it is mentioned as UK. Yes, islands are controlled by United Kingdom, but these have a very long history. What long history is that? The history is about the first person who reached to the islands of Falkland. Then, with further navigation, it was occupied by UK, then by France, then taken over by Spain, then UK and Spain had wars, and presently it becomes a dispute, not disputed, but the claim, Argentina is claiming this part. There's a slight conflict between UK and Argentina related to occupation of Falkland Islands. The islands are categorized as two ways. There are West Falkland Islands and East Falkland Islands. The West Falkland Islands, occupied initially by Britishers. These were discovered by Englishmen John Davis in 1592. Then were occupied later, and later on French occupied East Falkland Islands, and then it was taken over by Spanish, and there were a lot of conflicts between these two, which can be seen even in the present times. UK claims this islands. The name was given after the navigator Viscount Falkland. Viscount Falkland, right? The island has rich fishing resources because you would find that near these islands in the southern part, there is mixing of some currents, oceanic currents. One is the Brazilian hot current, warm current, and there is a Falkland current, that's a cold current. So whenever the two currents meet, warm and cold currents meet, temperature gets normalized and then fishing grounds develop. So it has a significance. There are two aspects of Falkland Island. One, fishing. Number two, strategic importance, okay, in the southern part. So you should look at these Falkland Islands and read more about it to know the claim and location of this. It's quite important. So now these are about the physical aspects of the region, the physical aspects of South America. Let's move on to the next physical feature, that is rivers of South America. Okay. So then we have major river basins, as in Amazon. Well, I think I don't have to mention much about Amazon. All of us know Amazon River. Amazon is the most voluminous river, and or it can be called as a largest river always in context to the volume it carries. And why not? Volume has to be higher. Now, why volume is so high? You should see the location of Amazon region, Amazon River. It is exactly at equator, receiving more rainfall, lot of dense forest, evaporation rate is less, so volume is bound to be higher. The exact source of Amazon is yet to be known. The exact source is not known because it's a dense network of tributaries. And they say that there are around 1200 tributaries, which form this massive Amazon basin. Okay, the largest among them, you can mark in your atlas, there's a river Madeira, that's the largest tributary, and then river Negro, that's the second largest tributary. That's the second largest tributary of this particular basin. So in your atlas, please go through atlas. These are very important rivers. So have a look at these rivers in your atlas. So massive Amazon river as it passes, then a river Madeira that is joining the Amazon river. It's the largest tributary. River Negro is the second largest tributary of river Amazon. So from exam point of view, this can be an important aspect, important question. Because we talk about Amazon rainforest, we talk about they call it lungs of the planet. We talk about their ecological significance, biodiversity, but little is talked about Amazon river. Mention about this, the largest river, the second longest river after river Nile, tributaries of the region. Another basin in South America is Rio La Plata. The Rio La Plata, in atlas you can see south of Brazil, near Uruguay, Argentina region. That is where the Rio de la Plata is located. So this river, this particular river basin includes river Parana, it includes river Paraguay, it includes a river Uruguay. These three rivers collectively form this river basin. You might be thinking, basin term, what is river basin? We are saying there's an Amazon basin, there is a Plata basin, or in India we say Mahanadi basin, Ganga basin, Godavari basin, and so on. Just a hint about what is basin area. See, let's take an example of an Indian river so that probably all of you can relate. We'll take an example of some river, like suppose Godavari we can take example, river Ganga, any river that you can see. And I want you to look at the atlas in the maps of these rivers. Let's suppose there's a river that originates. So here it is in Origin Head. Origin Head is the river, point where river originates. And it drains all the way, traveling hundreds or thousands of kilometers, and then finally drains into a sea that's called as mouth of the river. Okay, where it finally drains into sea. In between, the flow of river is augmented, supported by many other rivers. We call them as tributaries. So let's take an example. Suppose it's River Ganga, and River Ganga is joined by Alaknanda. I mean, it's Alaknanda and Bhagirathi at Devprayag, where it becomes River Ganga. Bhagirathi and Alaknanda. Alaknanda is joined by few more rivers like Mandakini, Pindari, and so on. Then Ganga is further joined by River Yamuna at Prayagraj. Then Yamuna is joined by Tons, Chambal, Sindh, Betwa, Ken. Then Ganga, if we travel further, joined by River Son. There are few more rivers draining from the northern side, or what is called as left bank tributaries, like Ram Ganga, Ghagara, Gandak, Komati, Kosi, and so rivers. Now, this entire area is called as the basin area of a river Ganga, starting from Uttarakhand till Bangladesh, you may say that. So, what is a basin area? All that region, all that area drained by the master river and its tributaries. The word basin is used because it looks more like a saucer shaped, like wash basin. The basin is more like that saucer shaped, where the sides are bit raised, central portion is bit depressed. So at the middle of it flows that river, master river, and from the sides, because the slope of the river, slope of the region is so that the river keeps on draining to a common point. So this entire area is referred as basin area. So coming back to what we were discussing, so one was Amazon basin, another is this Rio Plata basin. Basin 3 is to the north of it, Orinoco basin. The river Orinoco, you can see Guyana highlands, it is to the north of the region. It's again a very wide range of tributaries that the region has, and Angel Falls is also located on the same basin, on a tributary of river Orinoco. Then coming further east to the eastern side of Brazil, there is one more river called as San Francisco River, also called as San Francisco River. The river San Francisco is a tropical, mostly in the tropical region, goes from Brazilian highlands and does not have much of the flow during the drier spell because it passes through the semi-arid areas, so the water volume decreases. So it could not, it's not as big as the river as we have in the Amazon or Rio Plata region, but a significant river system of Brazil. Then there are few more rivers that you can see to the south of it. Again, the repetition of the names. One is Colorado and Negro. Now, a lot of people get confused. A lot of, while we are taking classes and they find this Colorado River and they find this Negro River that is in Argentina. You can see in your southern part of Argentina, they are located there. Now, the question is, which river should I mark? If the question is asked in exam about Colorado River, what should I consider? Because there are these two names, same name for the two rivers. Same thing is with the Negro also. Here we have a river Negro. Again, to the southern part of it, there's a river Negro. So friends, remember this. If Colorado is asked, first option is about USA, because that's a bigger river, that's a major river. As we mentioned in the first episode also, mostly Spanish population lived on the western coast of USA. So Spanish names are given to these rivers. So here again the Spanish is spoken most parts of Argentina. So again the name gets repeated. Same thing here, river Negro. So if question is asked about river Negro, my first option has to be, my first thought has to be the tributary of river Amazon. And for Colorado, the first thought has to be the river in North America that originates from Rocky Mountains and drains in Gulf of California. So often people face these difficulties because two rivers carry the similar name. So should be careful about it. So these are some important rivers. Now I just want to take you further here to two more locations, or maybe three more locations. One is this massive lake to the north of Venezuela called as Lake of Maracaibo. The Lake of Maracaibo. Okay. In the recent past, there have been so many events, so much of discussion going on about Venezuelan crisis, or US taking over the president of Venezuela, and a lot of geopolitics happening around this region. One of the reason is that Venezuela has huge reserves of petroleum. In fact, in 2015, Venezuela became the largest producer of petroleum. Now, it could not sustain that petroleum production for very long, but it became the first or top producers for some period of time. Now, it is not, of course, but has the largest reserves of petroleum. Where is it? It's in Lake Maracaibo. So, one of the significance that this region has, one of the largest petroleum reserves located in this lake. Between the lake, if you move towards north of the lake, there is Gulf of Venezuela. Okay, and therefore the Lake Maracaibo becomes important location for your atlas, for your exams. Lake Maracaibo is also in news for some reasons. Not petroleum, definitely not petroleum. The reason which probably none of us want to remember or none of us want to face. What is that? The region experienced huge, very high frequency of lightning events. In fact, maximum number of lightning events, if we consider since 2016, maximum number of lightning events in a year have occurred in this Lake Maracaibo, have occurred in this Gulf of Mexico, this Gulf of Venezuela region, these areas. A lot of lightning events have taken place. Maybe we'll discuss about lightning in separate discussion so that it doesn't overlap with the present discussion right now. But lightning events, you can see, have increased in number, very significant increase in frequency. There are few reasons. One of the reason is that there's huge amount of evaporation, a lot of charged particles getting into it, into atmosphere. Besides that, with the concretization, what we are doing is we are keeping the surface wet during the rainfall, and surface becomes good conductor of electricity. Then there are a lot of these steel getting used, metals getting used in the construction, making them as good conductors of electricity. So you see, lightning events have increased. Yes, there has been an effect of climate change with increasing evaporation, and they say that with 1 degree increase in temperature, the evaporation increases by 7%. So of course the evaporation rate is higher, it has increased. And also anthropogenic activities, particularly concretization and use of a lot of metals in the construction. So you would see some reasons, similar reasons contributing to more number of lightnings in this Lake Maracaibo and adjoining areas in the Gulf of Venezuela as well. Second lake, for that let's go to Bolivia, go to the region of Bolivia. The plateau of Bolivia has a lake, Lake Titicaca. Okay, Lake Titicaca. So you can mark that. It's highest navigable lake. Highest navigable lake in the world. Now, highest navigable, as we keep on climbing higher and higher, the atmospheric pressure keeps on decreasing. So navigability also keeps on decreasing. So this is the uppermost limit where navigation can be taken place. There is one more lake next to that, is Lake Pupo. Just mark that lake and we'll move to the next point then. Lake Pupo. So if you mark these 3 lakes, good enough. Titicaca, Lake Pupo, and then Lake Maracaibo. So these are aspects of drainage, rivers and lakes. So now another form, another physical feature, deserts. Deserts of South America. Look at western part of South America. Here, western part of South America. We have this desert stretching out from Chile to Peru. Okay. This huge desert called as Atacama Desert. Okay, the desert here, collectively Atacama Desert, but to this northwestern part, there's a desert called as Sechura Desert, and to the south of that, what is there in the region of Chile called as Atacama Desert. Atacama Desert. Now, one of the driest places on earth, right? Atacama Desert. The reason for the formation of Atacama Desert is the presence of cold current. There's a presence of cold current on the western part of South America. Now, what does this cold current do? Wherever the temperature of water decreases, like suppose it's a cold water current, this cold water current is because of upwelling of water. Right? There are few, these winds which go from east to west, southeast trade winds in southern hemisphere, northeast trade winds in northern hemisphere. On the western margin, as these winds blow off the coast, they also push the water, tropical surface water, towards west. Since surface water goes towards west, there's an upwelling of cold water that happens. It is something like if we have a warm water along the surface and winds carry them towards west. As a result, it gets carried away and the cold water upwelling can take place. The cold water upwelling brings some positive effects also, like it helps in fishing, etc. But because of the presence of cold water, air in contact also remains cold. It becomes dense, and the cold, dense air causes subsidence. It starts sinking. And because of the sinking of the air masses, because of the sinking of the cold air, deserts are formed. Sinking air brings atmospheric stability. So remember, for rainfall to occur, an air mass must rise up. Only then it will saturate, it will condense and can cause rainfall. Relative humidity can be supersaturated and so on. But if an air mass is sinking, the sinking air masses do not cause rain. So cold water creates that condition where air masses will sink. In some explanation, you may also find that cold current gives rise to the less evaporation, and less evaporation is a cause for dryness. Partly true, but most importantly, it has to be linked with the sinking air masses. In the last discussion, we mentioned subtropical high pressure. Please add that point as well. Subtropical high pressure zones are zones where air masses continue to sink. And these sinking air masses do not cause rainfall, which gets more intensified in the regions of cold currents. So here there is this cold current called as Peru current or Humboldt current. Peru current or Humboldt current. Humboldt, Alexander von Humboldt, a German geographer, is also called as father of climatology. He was the one who explained the relation of cold current and desert formation, and many more like permafrost, continentality, impact of currents on the Cuban tribes, and so many contributions. For him, Alexander von Humboldt is called as father of climatology for his contributions that he made, and we named after him this cold current. Although the effect is not that positive, it brings deserts, it creates desert. here in Atacama region and Sichuan Desert to the north of it. So you can mark to this. Then we have one more desert, Ligora Desert, La Gohira Desert, that is there in Colombia and western part of Venezuela. So exists in Colombia and western part of Venezuela. It's again closer to the subtropical areas. I mentioned earlier, subtropical regions are usually drier zones and they cause sinking of the air masses to create desert formations. One more desert that stands out in South America is the desert of Patagonia in Argentina. So in the southern part of South America, in Argentina, eastern side, you'll find Patagonia Desert. Now the reason for the formation of this Patagonia Desert, one, you need to look at the latitudes. This is my suggestion for all of you for your prelims examination, for your mains examination. Like there was one question asked in your exam, in mains examination, question was asked, most of the tropical deserts are located between 20 to 30 degree latitudes. Why are deserts located on the western margin of continents? So for that you can take these examples, that 20 and 30 degree latitude deserts are located because of presence of subtropical high pressure belt. Western margins are because of offshore winds, presence of cold currents, and so on. So you can see in tropical regions, tropical deserts are located mainly towards western margin of continents. But in the mid-latitude regions, somewhere between 30 to 50 degree latitude regions, you find some of the deserts located towards eastern side of it. Here we have this desert known as Patagonia Desert. So my suggestion to all of you, whenever you look at a desert, you find a desert and you have to explain why deserts have been formed and how they have been formed, just look at its latitude first. So by this latitude, as you look at this, it is very well in the westerly zones. Winds which blow from 30 degree latitude to 60 degree latitude in both hemispheres. And since they flow from the west, they are called as westerlies. Now, as the winds blow from the west in this region, there is a wall of Andes that stands, causes obstruction. Western region gets rainfall, but eastern region does not receive rainfall. So this desert has been formed because of the rain shadow effect caused by Andes. So friends, go through this, look at your atlases once again, look at your atlas, bring in your concepts of climatology, bring in your concepts. So what you see here, that on the western margin, Andes, westerlies come from the west and they cause obstruction, Andes cause obstruction. This lies to the drier side, the rain shadow region, and that's why Patagonia Desert has been formed. Now some of the people get confused here. I get this question repeatedly in the class, that when they look at the atlas, there is a cold current to the eastern side of it. Here there's a current called as Falkland current. The Falkland current is cold current, so Patagonia Desert is also formed because of this current. See, the primary reason for the formation of this desert is the rain shadow effect of Andes. If I have to choose one option, I will go for the rain shadow effect, because Falkland current does not show, it gets intermixed with the Brazilian current also, so does not have that effect of dryness in the region. It is different on the western margin of continents in tropical areas. Okay, it's a cold desert, massive desert, and you can also read about this desert in context to the biodiversity of this region. Right, so this is about desert formations. Okay, towards the end of the discussion here, we shall look at some of the low-lying lowland regions or the vegetation regions of this. So again, go back to your physical maps, physical map of South America. I want you to locate some of the places. See, first here, Amazon region. Sorry. First here, Amazon region. Okay. Then to the north, then to the east, then to the south and the central regions. There are specific vegetations that we find in South America. Let's see those. See, if we look at the northwestern part, like here in the northern regions, it's written as selvas in your atlas. It's written as selvas. Selvas is a name given to equatorial rainforests. Okay, forest. So Amazon rainforest, basically called as selvas. The reason why it has so much of rainfall, equatorial areas, more evaporation and so on. To the north of it lies another grassland region called as Llanos. Llanos is a tropical grassland region. Tropical grassland region. Along with the Llanos, Campos. It's again a tropical grassland region in Brazil. Llanos is a tropical grassland in the Venezuelan region, Venezuela, and Campos is a tropical grassland in Brazil regions. Yes, why grasslands are formed? These are formed in the regions where rainfall is less than 60 centimeters in 1 year. Because we require more than 60 centimeters for forest cover to exist. And here, Campos is slightly interior. Brazilian highlands, to the interior of Brazilian highlands is the Campos region. The rainfall is less, it's a semi-arid area. And since being in the semi-arid regions, rainfall is low and grassland regions develop in that ways. Go to the further southwards where there is Gran Chaco. Gran Chaco. Gran Chaco is a tropical deciduous forest. Deciduous forests are those which shed their leaves once in a year. Okay, they shed their leaves once in a year. And the Gran Chaco has some importance. The forest cover lies in the Uruguay and Paraguay region. It is rich, it is known for balsa wood. Balsa wood. Balsa is lightest and the most durable wood. Lightest and the hardest wood in the world. Extensively used for the shipbuilding. Okay, considered as lightest and the hardest. Used for shipbuilding across. So locals even call it as axe breaker, Cuo Braco, because of its hardness. Further southwards lies the Pampas region. Pampas is temperate grassland region. It is the temperate grassland region, Pampas. And remember episode 1 where we mentioned grasslands, that too in the temperate regions, they have less evaporational rate compared to the tropical grasslands. So Llanos and Campos are drier, they're tall nutritionless grasses that grow because evaporation rate is high, the nutritional values are low. Temperate areas, temperature is low, evaporation is less, the moisture remain intact with the soil, organic content is higher and therefore used for wheat cultivation. So Pampas grasslands have agricultural significance, used for agricultural activities, also used for livestock rearing. Also used for livestock rearing, because these act as pasture lands. So these are some of the physical aspects where you can integrate your prelims as well as the mains preparation. Do not segregate them. You have to study them in integrated manner. Don't consider that there's a separate preparation required for prelims examination or something. Prepare yourself for overall concepts, memorize some facts, go through these maps again, get familiar with these maps. And now we will be looking at some other aspects. What are those aspects? The aspects, political aspects, wherein we will start with the significance of this strait called as Strait of Magellan. Now, when Magellan reaches to this strait, they say that he cried of joy because he found a new way to reach to western part of South America prior to the opening of Panama Canal. And what did this Strait of Magellan meant for the expansion of Spanish colonies? How did it happen, and how did it shape the political aspect of the continent, controlled by Spain for very long duration of time to check their other European rivals not to extend towards Pacific? And therefore you see a lot of Spanish colonies in the western part, starting from Chile, Peru, Colombia, all the Central America. The Strait of Magellan therefore was such an important discovery, such an important route discovered towards Pacific. Why not Drake's Passage, which lies to the south of it? Why not other features? And how did it shape the political significance or political arena of Latin America or this entire continent? That we'll discuss in the next episode. So I'll see you there. Hope you are enjoying it, and come up with the episode 4, where we'll be looking at the political aspect of South America. Thank you.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.